So thank you for watching this video. This video is going to be three examples, three graphs of quadratic functions. And I'm going to go through and identify everything that you can possibly identify for this function. We're going to do the y-intercept, the x-intercepts, if there are x-intercepts, the maximum, the minimum, the max or the minimum, the vertex, the axis of symmetry, where it's increasing, where it's decreasing, the range, the domain. I think that's everything. So let's get into this example. The first thing I always start with is the vertex. Now, usually I've made these so they work out, but usually if you are graphing a quadratic function, whether it be on Desmos, then you can click on it and you can see the vertex. It gives you the vertex. If you're doing it on a graphing calculator, you're going to need to calculate and double check, make sure that it is actually, does it actually cross there, or does it cross at -2 and 8.005, right? Like, where does it actually cross? I personally, for these examples, have made it cross perfectly, and I would say most teachers would make it cross perfectly on these whole numbers if it looks like it's supposed to. So -2, 8, -2, 8. And that should make sense because this is in vertex form, and h in this case is -2, and k in this case is, if I can draw an 8, so -2, 8, vertex form. So -2, 8, that is my vertex. Based off of the vertex, I can get a couple of things. The first one that I will draw in would be the axis of symmetry. So the axis of symmetry is the axis of which the points on either side of the vertex are reflected across. And that is x equals the x value of the vertex, so -2. So that is the axis of symmetry. Can I zoom in a little bit? Yeah, let's do that. So we got that. We can also get whether we have a minimum or maximum. Now looking at this, I know I have a maximum. This point is the highest point. Everything else is below it. So I have a maximum, which happens to be 8. That is the highest output you get is 8. So maximum, and that is of 8. All right. So we got our maximum, which is 8. We got our vertex. We got the axis of symmetry. What else can we get? Let's look down here. We can get the y-intercept. Now, something special about this y-intercept is this y-intercept is actually also an x-intercept. So the y-intercept would be 0, 0. But that also happens to be an x-intercept of 0, 0. The difference is we have another x-intercept over here. We only have one y-intercept, but we have another x-intercept over here. And that is -4, 0 for that point. All right, we got our y-intercept, our x-intercept, we have our maximum, axis symmetry, vertex. What else can we get? We can talk about increasing, decreasing. So what color do I want to use? Do I have? I'm gonna use a purple pen. So increasing, decreasing, and that's where the function is increasing, decreasing. Now, these arrows at the end of a function, which symbolize that they go forever to negative infinity, which is true, but they can be misleading, I feel, when first learning when things are increasing and decreasing, because to students, it looks like, oh, it is decreasing because it's going down. the arrow is pointing down, it's decreasing, but it's not. Decreasing and increasing work as we go from left to right. So as we go from negative infinity to positive infinity, on the x-axis, what is happening to the function? So this point is actually left of, like, let's say I pick a point here and I pick a point here. This point is to the left of this point. So as I go from left to right, what's happening? As I go from left to right, we're actually increasing, right? And then we continue to increase all the way up until this point. And then at that point, it starts to decrease as we go from left to right. And it decreases all the way forever, never, never, never down. All right. So increasing, decreasing is from left to right. So from this side of the axis of symmetry for the quadratic, from the left side, we are actually increasing. It is increasing over here. And then from this side over, we are decreasing. Okay. Now, how is that represented? So some teachers might just say, where is it increasing, decreasing? To the left of the x-axis, it's increasing. To the right of the not x-axis, of the axis of symmetry, it's decreasing. But we can answer that also with an inequality. So what x values are where it's decreasing? And those x values are, or I should say increasing, are when x is less than -2. So all the way over here, all the way up until you get to -2, this function is increasing. Not including -2, because at -2, there's no slope, right? It peaks and it's flat. It's not increasing anymore. It's reached its peak, its maximum, the vertex, the turning point, change in direction, okay? So all the way from here over, it's been increasing. But then starting here, it starts to decrease again for these x values. So decreasing at x is greater than -2. So those are represented by inequalities. Hope that makes sense. We're going to do it 2 more times. Like I said, this video is going to cover 3 examples. The last thing I want to talk about for this is domain and range. So if I can fit them in, let's just put them over here. Domain, range. So domain and range, the domain are the x's. So domain, all the x's that are used, all the inputs that are used. So these are the x's, and these are all of the y's that are used, or all the outputs. So if this continues to go down, and as it goes down, it gets wider and wider and wider and wider, and it's going to continuously go down forever, which means it's going to get wider forever, which means it uses the whole x-axis. So one thing you can say for domain is all real numbers, because it's using all of the real numbers on the x-axis, everything. Other teachers might have you do interval notation, -infinity to +infinity, if I can do the infinity symbols. So this is how I want my students to be answering. Just all real numbers, capital ARN, all real numbers. All right. The range is different though. We don't use all of the y's. We have a maximum y value. We don't go beyond 8. But we go down to -infinity, but we don't go past 8. So this goes down forever. So everything below or equal to 8. And as an inequality, that looks like this. Y is less than or equal to 8. Because it is everything less than 8 or equal to 8. Right? It can be equal to 8, 7, 6, 5, 4, all the way to -infinity. All right. So this is how you answer the range. If it's a maximum, then you have less than. If you have a minimum, then it gets greater than or equal to. So let's do some other examples. Let's go to this one. So I'm gonna do a little less explanation on this one. I'm just gonna go through and identify, for the most part, everything. So got the vertex, which happens to be an x-intercept also. So my vertex is 2, 0. Also happens to be the x-intercept. So this is also x-intercept. Now it's the only x-intercept. This doesn't cross twice. It touches, the vertex touches the x-axis. So there's only one x-intercept. Based off of the x-intercept though, or the vertex, we can get the axis symmetry again. So the axis symmetry, draw that in. And that is x equals the x value of the vertex, so 2. We also are going to get that we have a another maximum, but the maximum of this case, instead of it being 8, the maximum y value is actually 0. So maximum is 0. Where am I missing? Maximum, it's right here. All right, get that drawn in. So maximum is 0. We got the vertex, we got the axis of symmetry, we got the x-intercept, the only x-intercept. Let's get in the y-intercept, which is right here. So we got a y-intercept of 0, -4. All right, so 0, -4. Got the y-intercept, x-intercept, maximum, axis symmetry. Let's do increasing, decreasing. So from left to right again, as I go from left to right, so as I start here and go to the right, I am increasing all the way up to this point. So again, to the left of the axis symmetry, we are increasing. So when x is less than 2, and over here we are increasing, not increasing, sorry, we are decreasing when x is greater than 2. All right, so we got our increasing, decreasing. What else do we need? Domain and range, I think, is it, because we got our axis of symmetry, maximum, x-intercept, y-intercept, vertex, increasing, decreasing. So domain range, the domain always is always all real numbers for a quadratic, no matter what. The range, though, differs. So the range for this one, it is going to be less than, because we have a maximum. So it's everything less than the maximum or equal to the maximum. So y is less than or equal to 0 is the range. All the y values, every y value is less than or equal to 0, starting at 0. All right. That's everything for this one. All right. Do last one. So this one had one x-intercept. This one had one x-intercept. This last one had 2 x-intercepts. All right, got our 2 x-intercepts. This one has 1 x-intercept. This last example has 0 x-intercepts. So we don't have a single x-intercept here. We do have a vertex, because we'll always have a vertex, which is 0, 1. Also happens to be the y-intercept too. So we're doubling up again. So this one is the y-intercept also. So also the y-intercept. All right. Little more difficult to draw in the axis of symmetry when the axis of symmetry is the y-axis. Just do your best if you get a problem like this. Helps if you got color, so you can put a little bit of color on it. So that would be x equals 0, right? The x value of the vertex, so x equals 0. And there's no x-intercepts, so there's no x-intercepts. We got the y-intercept, we got the vertex. Let's do the minimum. The minimum for this one, because everything gets greater than, instead of the other two where we had maximums, this one has a minimum. So the minimum value minimum in this case would be 1. That is the lowest value. Everything is greater than 1. So we got minimum, vertex, y-intercept, axis of symmetry. Let's do increasing, decreasing. So this one's also going to flip on this. As we come from the left to the right, we are now decreasing on this side all the way up until this value. So we're actually decreasing over here now when x is less than 0. And we start to increase over here when x is greater than 0. All right, now we just got our domain and range. So domain, all real numbers, always, range, changes. So domain, all real numbers. The range, a little bit different. So we're gonna have y is what? Is y less than or equal to 1, or is y greater than or equal to 1? It's greater than or equal to 1. All right, so instead of being less than, like the other ones, it's greater than because we're getting more than 1. Right, we're starting at 1. I guess we don't start at 1, but that's the lowest point, and then everything else is greater. It's more than. Okay. That's everything for this one. There are no x-intercepts at all for this one. Really important, don't get your symbols mixed up. These ones are not equal to 0, not equal to 0. They're just greater than 0 or less than 0. This one, though, is equal to because the vertex is a point, right? We include the vertex. So everything greater than or equal to 1 works for the y values. But for here, it's not increasing or decreasing at 0. It decreases up to 0, and then after 0, it's increasing. At 0, there's no slope, I guess. There's no slope at all. If you take pre-cal or calculus, whenever you do derivatives, you find instantaneous slope, it would be 0. There's no slope there. There's nothing. It's not increasing or decreasing. So that's it. I hope this video was helpful. For my students, I'll be posting these notes also onto Google Classroom. So thanks for watching. Give it a like, I guess. I feel weird asking for that. I'm not a YouTuber. But yeah, give it a like if you thought it was helpful. I guess that does help me know whether or not it was helpful or not. Thank you for watching.